one last part about this is the high voltage side, and I can't show that on the scope, unfortunately, because the scope can't read that high, especially I only have 5 volts per division. So it's quite interesting because you have 12 volts coming in and this transformer creating this crazy buzz, and that oscillation will amplify this voltage just like it does for the sparks actually. But if you want to see that in action, this is the 12 volt side. So if I have that, that's 12 volts to ground. Minus 12, I have the probes in reverse because the high voltage is hooked up with the 12 volts as a reference. That's the car battery, and if I go to the high voltage side of the coil, and you can see that's reading 533 volts, and that's pretty crazy that I can do that. And so that obviously multiplies to the thousands of volts through another similar thing to this coil. Yeah, this is measuring between points N and G. And G is the probe and N is the reference. Yes, that's correct. Okay, so I turn this on and I see something I didn't expect. This is a ringing on the ground. That's at 1 volt per division, so it's about, it goes negative a little bit and then up about 1 3/4 volt. That's with the points closed. If I rotate this, the points are open. Now it's a much cleaner signal. It has the same pulses, but they're much more reduced. So not sure where all that noise is coming from. So this is obviously still working. And then I turn, and you can see this big spike there, so I need to adjust this so we can see that spike. So now it's 5 pumps per division. I need to adjust the trigger. You can see those spikes are about 12 volts relative to ground, which is higher than I would expect. Here's a better view of that. So there's that spike, and yeah, a little over 12 volts. Very short spike. That's 5 milliseconds per division. Is that? Yeah. And the ringing is about 0.5 milliseconds per division, so it's 0.5 millisecond noise. Anyway, somehow I think that resistor is collapsing, and the inductance in the resistor is what causes the voltage boost as the current from the capacitor runs through it and resist that change. Okay. All right, now I'm across 3 and N, which is just the capacitor. And so I move this probe to 3 references, still at N, same setup. Okay, if I turn this on, that's with the points closed. That's with the points open, closed. So open is basically 0 volts, closed is negative almost 12, no 10. 510, yeah, that's about right. For the resistances involved, that should be exactly right. But you'll notice that when I run this, I set up a nice square wave as that goes, but you don't see any high voltage spikes. So it appears that that voltage spike certainly does not come from this capacitor, which is reasonable. Okay. Now I'm across G and 3. I would have expected to see that spike again, but I don't. So this part I'm a little confused. This has virtually the same behavior as just across the capacitor. And then the spark, you see that? And then if I zoom up, this one, you can see there's about that's 1 volt per division, so it's maybe 2 volts above, but it doesn't do what I would have expected. I don't see any spike there. So I need to still explain that. Alright, for a sanity check here is G to 1, which is the battery voltage reference, and the reference that's across the thyristor. So that's 0.1 to across G, where G is the probe and B is the reference. And so you'll see I'm on ground. This is 0. So the voltage at steady state is slightly lower, which would keep the thyristor closed. And then you can see these spikes come through. If I run that, you can see the spikes. If I don't have a trigger as well, you can see those. If I make it quicker, you can see what the shape of that spike looks like. But the spike is up about 3.5 volts or so. So somehow that collapsing of that resistor is causing that inductance, I think. That is my guess. Okay, last one. So just for sanity or more checking, this is going to measure point G across ground. And so ground here, here, any of these. And you'll notice that ground is just opposite of the 12 volt supply, which makes sense for a car. So we would expect to see pretty much the same behavior as if you're measuring G to 1, which is the 12 volts. It's just that everything would be biased 12 volts higher, but you should see the same general behavior of the spikes and stuff. So in order to see that, you have to set the scope here. I've now set the scope to 0 at 5 volts per division and down here so that you can see what's going on. So when I turn this on, see it jumps up. So that is 12 volts. So it's going up 2 divisions, and so yeah, 12 volts. And you can see the 12 volt line is pretty noisy, so this box adds a lot of noise to the line. Probably not so great for radios and such. Anyway, but when you do run the points, you do get that spike right there. And that's actually 5, 6, maybe 7 volts higher than even the biased 12 volts. So again, that's working, and that does have the same behavior as the just across the resistor, or just across line 1, just that everything's biased 12 volts. So that all makes sense. Yeah, one more time for the spike.